So my name's Richard Tomlinson. I work for Oracle now. I've been working for Oracle for about 4 months. We just got acquired. I was at Endeca Technologies for about 5 years prior to that. So I'm still getting used to this big machine, and I probably will say lots of things I shouldn't say and have no idea about the process yet. But, so I head up product management for the Endeca Information Discovery product, which is formerly known as Latitude when we were Endeca. So if you have any questions about that or need to contact me afterwards, please feel free. And I do want to talk about Lexalytics today, but I just wanted to give you a little bit of history about the company and kind of what the space that we're in and what we do, just to bring you up to speed before we get into some specifics. Essentially, we are founded out of Cambridge, Mass, right here, in '99. Spent the first couple of years in R&D mode really trying to design a new type of search engine analytic database that can really address any type of data, be it structured, semi-structured, or unstructured. When we went to market in the early 2000s, we had a lot of initial success in the e-commerce world. So everybody in this room has probably already used Endeca, whether you know it or not. If you've ever been to Walmart.com or a Nike store or Home Depot or Target.com and searched for a product and drilled down on the left-hand side using guided navigation to look at specific brands, or within that brand, specific price ranges, and then maybe specific review ratings, and you keep narrowing down until you are left with 3 or 4 products that you're interested in purchasing. That's Endeca. That is indexing that product catalog, indexing all of that raw, unstructured text, and also summarizing all of that unstructured text by all of the facets associated with that text. So you'll hear guided navigation, faceted navigation is a key piece of IP for Endeca, which is really where we came to market. So I'll show you some of that concept in some of the demos I've got for you. But essentially, so I now work in the Endeca Information Discovery product, which is taking the same engine, the same search engine, and instead of indexing product catalogs and CMS and document repositories for people on the web, we're indexing enterprise data, CRM data, data warehouses, social media, and really anything, and offering that to kind of an internal community of analysts, business intelligence, consumers, et cetera, et cetera. So yeah, really our core IP is the kind of little cube there, which is Endeca Server. So that is a hybrid search analytic database that was built from the ground up to do very advanced search and summarization analytics. So I'm not going to spend long on this slide, but because we've all realized that there is a market for this now. But from an Endeca perspective, we've been around since the early 2000s. We've always been very agnostic about the particular type of data that we go after. So we love the fact that there's the big data movement, there's the variety of data, we really love to embrace this new world. It fits perfectly with our product. And from a business intelligence perspective, which is where I spend my time, more and more customers I'm talking to want to bring this new type of data into their business intelligence infrastructure so they can add it on top of the reports and the insights that they're providing to their consumers already. I think one of the things that really fits nicely with Endeca is that because of this new type of data, you could never possibly model it in a traditional sense of relational models. And even if you could, it would probably, the schema would change tomorrow because a whole ton of new data comes online, or your existing data sources start exposing 50 new attributes and you didn't anticipate that in your model. So these kind of rapidly changing requirements from business analysts need a very flexible architecture. You don't need to go build a data model up front before you can provide any business value back to the consumer. Compound that with the fact that in the BI world, users are really savvy these days. So they've no longer just been to a training course and they know how to click on refresh on their favorite report every Monday. They're kind of mini data scientists themselves. They go out and explore Google. They know how to do research. So the product that we bring to market needs to kind of facilitate the much more sophisticated type of user that's using lots of different types of tools and getting the information they need pretty much on their own if it's not in their BI system. So just from a real 50,000-foot level view, the Oracle Endeca Information Discovery platform is a platform for discovery. So we're a 3-tier architecture. As I say, our secret sauce is really in that middle tier, which is called Endeca Server, which is our search index. But we also have a studio tier at the top level, which allows kind of business users to drag and drop, build their own BI applications without really any knowledge about the data, without any knowledge of code. So it's a portal-based technology, and I'll show you some of that in a second. At the bottom level, we have an integration suite that we have developed by OEMing various technologies into our stack. So we leverage structured ETL or traditional ETL tooling to kind of do that load, transform type stuff that we're used to seeing in the traditional data warehousing world that works very well on very well-known sets of data. But then our integration suite also covers various content management system connectors, crawlers, scrapers, and we integrate with web-based APIs, web services as well. So you've really got the best of the kind of structured and unstructured ETL. In terms of Lexalytics, it's part of that bottom integration suite tier. So as we are moving data from source systems into the Endeca index, we're applying Lexalytics along the way. We're pulling out entities, we're pulling out topics, leveraging their sentiment scoring, et cetera, et cetera. So this is about as technical as this particular deck gets to, but just for those of you that are interested, the way Endeca Server is actually physically designed is that it's a key value store, more like a kind of NoSQL approach. So there's no relational model, there's no schema to build up front and then try and crowbar this data in, which is really advantageous in this new world, as essentially as we pull data in, it's being indexed and it's designing its own schema on the fly. You get the ultimate level of flexibility if you're just managing key value pairs. So the demo I'm about to show you actually leverages the DataSift API, which is pure JSON that we capture in real time. We never really know what that's going to look like ahead of time. Twitter might decide to expose new attributes through their APIs. Facebook might decide to do that. DataSift might decide to add new sources and new enrichments. And we don't need to know any of that in advance, because as the data flows in, it's just exposing itself and building or extending its own internal data model on the fly. What that gives you from an end user perspective is a kind of an end user experience for I wouldn't say data scientists, more just traditional analysts and everyday people, to just start wading through lots and lots of different information, wading through hundreds, if not thousands, of attributes, and using techniques that they're very familiar with already to do that. So, at one end of the spectrum, you've got people that are very Google-centric. They hit Google all the time. It's keyword search. You need to have thesaurus, spell correct, relevance ranking, stemming, all of those traditional search techniques that you expect from a full-featured search tool. But at the same time, anything that or facets that exist on the content that's being indexed should also be exposed and summarized, so you can start to drill down on those. So if you've got authors of the articles that you're indexing, summarizations of those authors, summarizations of the dates and the times that the articles were created. So that faceted navigation is something that you can just click on, and it reduces your analysis down to what you just clicked on. And then finally, obviously at the other end of the spectrum, you need a way of understanding all that information. So we provide, pretty standard visualization, mapping, all of that type of capability. In terms of use cases, I mean, we've actually been working with Lexalytics since about 2005, I want to say, maybe a little. 2007, so it's a fair amount of time, and we've actually got sample customers in a wide variety of different vertical markets doing different things. Some of the most popular ones right now is obviously web commerce, so being able to navigate or shop by discovered attributes and discovered terms, such as what's pulled out of review content, for example. Just additional ways of faceting the data to narrow down to a set of products you might be interested in buying. We also, it's a really hot topic, lots of stuff about social today, but we also are frequently asked by our customers to provide insight into social media data, either surfaced through APIs or just pulled and scraped off websites on a case-by-case basis by crawling technology. And then they want to not only just understand that social data that they collect, but they actually want to mash that together with their supply chain data. They want to mash it together with their CRM data. They want to mash it together with HR data, with whatever they have in their enterprise. Often it's in their data warehouse. They want to actually just use social as just another lens into the whole the BI architecture. And then a couple of others where we're pretty strong. We're in every automotive, all of the automotives. 3 of those automotive customers of ours are using Endeca and Lex to actually understand the customer verbatims that the dealers collect when you take your car in and complain and say something's wrong with it, and they register a warranty claim. That dealer's taking tons of notes at that point. So being able to leverage that unstructured text and the attribution that's discovered in there, in conjunction with the more structured attributes such as the cost of the repair, the part that was replaced, the supplier that supplied that part. But just really combine all of those structured attributes that they've looked at in their warranty analysis with the customer conversations or the dealer conversations. And that's the same concept with contact center analysis as well. There's people calling in to 1-800 numbers through service centers, having a dialogue with a customer services rep on the phone. That dialogue is being digitized and translated into text. Lexalytics is great for pulling out interesting things that are said during that conversation. You can then combine those with all of the traditional contact center metrics and contact center attributes that have been around for a few years now and people are used to. So with that, enough slideware, and I'm going to show you a couple of demos. They're kind of cool demos. They're kind of in the intelligence space. One of the demos, one of them uses the DataSift API, so I'll show you some of that lovely data that we were seeing earlier today and actually how you can interact with that. We actually helped the Chicago police a couple of weeks ago monitor the social traffic around the Nato summit. So we had a real-time social analytics application up and running that they could watch all weekend, and they gave some really interesting terms to watch out for and user accounts to look out for. So we'll see some of that. And then kind of an extension of that, we've got some data that we scrape from the National Counterterrorism website. So they actually keep a record of every terrorist incident that's happened in the globe in the last 10 years. We've pulled 15,000 of those incidents into Endeca and done or processed that data with Lexalytics, then there's certain terms that Lexalytics pulls out, places, people, themes we've actually used to seed social media. We use DataSift, so we can look at terrorist incidents and then what people are saying about those incidents through social media channels and expose relationships between kind of very, very different data sets that definitely have relationships that would be difficult to pull out in the past. Any questions before I go on? No? Okay. I'm just dealing with a couple of resolution issues here. Is that good? That's kind of difficult to see, but so this is the Nato summit demo, and I'll just kind of walk you through some of this interface first before you feel like it's just way too much to consume in one go. But essentially, we've got summarizations here on the right-hand side. Through various ways, we can summarize with charts and graphs. Various kind of traffic lights, all that standard stuff. We've got the dreaded tag clouds, ways of summarizing information as well. Various ways of actually just showing roll-ups. And then at the bottom, we're actually pulling, we're actually, we're not pre-aggregating and throwing away the post. We're actually keeping the post in the engine as well. So all of the individual conversations are in here. Then on the left-hand side, it's just really ways of navigating and exploring the data. So you can start to search through the data based on anything that you might be interested in, such as the word protest, and it'll expose, and I apologize for language again, there's no profanity filtering going on in any of this. It'll use, so you've seen this type of technique before where you type in a search box and it uses type ahead to start to look across all of the attributes that we've indexed. So not just the actual content of the post, but if the user has the word protest in their in the username or in their user profile, because we're getting that attribution from DataSift, we'll expose it. And then it might be their name. It might be really it could be anything. You can also just hit return and do kind of issue a standard search. So you've got all of your posts here that match that search term, and you can see that some match the term on the content of the post, some match the term on the word protest actually within the link of the tweet that they were forwarding in their tweet as well. And then what you'll see here is actually ways that we expose some of the Lexalytics attribution. So you can see here that in terms of these are themes, we've got final day, we've got, this is all kind of, it looks a lot better on my laptop than it does on here because I have better resolution. But these are all the themes. We can flip the perspective here and look at entities if we wanted to. So we've got some of the entities that are being pulled out there. I will... if I want to just kind of refine to a certain type of entity, we can look at, let's look at places, for example. I can hit that, hit submit, everything re-summarizes, and I can see all my entities that are actually places now. Obviously, Chicago you would expect to be a big one because the NATO summit was in Chicago, and that would be the word in the tag cloud that we wouldn't like, so we can actually go down here into entity's name and actually, one second, exclude that from our analysis. So we're not looking at Chicago and filter out noise that way. So it's kind of a very interactive way of just digging down and exploring the data and watching all of the attributes just refresh and reflect what you've just clicked on or what you've just searched on. You can keep going. I mean, here's for example, the distribution of Clout Score across those search results. So of the 2,000 posts and tweets that we have, we can kind of look at the high influencers. So I'm looking at everybody that has a clout score between 50 and 73. And then if we want to, let's just look at sentiment here and take negative only sentiment. So now I'm down to 95 posts. So that's out of about 360,000. And the police really loved this because they don't know what questions they have up front, what they want to ask of the data. So they just start hitting search, they just start hitting guided nav, start drilling, and they just start drilling, and things pop up, so interesting terms. Oh, talking too much. Interesting things just pop up. In terms of sentiment, I thought it was kind of interesting when I looked at. Thanks very much. Is that plugged in? Okay, in terms of sentiment, you saw some of this earlier. We actually had. Let me try and show you this a little bit better so you can see. Okay, well, there are days down here at the bottom. This is the actual weekend that we recorded over. And let me see if I can do this somehow. Yeah, there we go. So we can see that this is a trend in terms of sentiment. Obviously, because it's NATO summit. Sorry?
I was just saying
10 minutes? Okay. I thought it was showing me jazz hands then. So this is the trend. Sunday was the big day. The process was Sunday and Monday, so we saw obviously a huge spike in traffic. And then if you drill into that particular day, obviously see a big spike in traffic and in negative sentiment at this particular time period. And this particular time period is just so happens is when all the riots started to kick off and the police started to intervene. So we're now looking at that particular, just a distribution of sentiment over that one particular hour. And if we need to, we can, we can take a look at the individual posts that correspond to just that hour. Okay, let me delete that and zoom out again. Obviously, we're getting everything from DataSift, so they actually give us about an average of 50 to 60 attributes per post or per interaction. So we just have the ability to look at any of the data from any angle. Obviously, people like to use geocoding, or some people like to geocode enable their apps and their Twitter accounts. So if there's geocoding going on, we can tell exactly where people were when they actually tweeted. And then there's the links as well. So again, interesting for the police was what were the most popular articles and links that were being sent out. All of this stuff is dynamic. So if I wanted to look at only stuff that was negative, only links that were very negative, I can just show negative sentiment, and now I'm looking at just negative sentiment-related articles. I've got the individuals themselves, the authors, and then just as I kind of call it clouds here. These are all and there it is, the word Chicago in the word. Now you would expect that. Good. So just kind of a very general flyby of this type of data. I think some of the cool stuff about this is we were testing the real-time capability of DataSift, and we were finding it was anywhere from about 1/4 of a second to 1/2 a second between hitting send on Twitter and it actually showing up in this application. So really phenomenal performance considering they're processing this in real time and adding Lexalytics and a whole host of other enrichments in real time. So really powerful, really useful. Because we were asked to set this up in such a short space of time, I had a really ugly architecture set up. So there's actually the DataSift API in the UK providing data over its API to my MacBook Air here running Windows with Parallels on it. that was then processing that data and sending it to Amazon EC2 Cloud, which is where this Endeca server, the search index, is. We had cleaners in on that Saturday, and they shut the lid of my laptop, which, so my phone started to go off. What we were able to do, again, I can't say enough about DataSift, but because we're actually getting a persistent connection to the real-time API, we're also recording at the same time in the cloud. So what I'm able to do is, while they're going on and looking at the data that's coming in real time, I can actually patch up and backfill the half hour that the lid was closed by just pulling out a little extract of that recording and layering it on the top of the index without the index needing to be taken offline or without any interruption in service for the people consuming the application. So that was really, really nice. And I've got 5 minutes left, and I don't have much of a demo path on this one. But this kind of gets to, and again, I've got lots of internal demos, but it's customer data, so I have to kind of stick to what's publicly available. But this is the NCTC, the National Counterterrorism Database, about 15,000 incidents over the last 10 years, 12 years. And you can see lots of ugly things that we can generate, like the number of people killed and wounded. As I said, the NCTC site exposes certain attribution against its search results. We actually just crawled the site using Kapow. Somebody else was mentioning Kapow earlier, but that's a really good scraping technology for not only grabbing the text, but actually kind of splitting it up and recognizing a date, recognizing an author, and attributing that. So that's why I can get this the event types, things like weapons, and then we use these terms to actually to seed DataSift to get related posts based on keyword hits on these types of terms. So again, if I type in kind of interesting terms for this type of data, you can see my social media data at the same time as my actual incident data refreshing based on that particular search term, and you can see the discovered attribution that we've got from Lexalytics kind of making really changing dynamically based on what we picked as well. Yeah, there's lots of interesting search terms I can type in here. I think finally one of the things I like about this demo is this concept of a join. In SQL, in traditional SQL terms, you have to have a key to join on if you want to relate two different types of data. Well, here we've got a terrorist incident with a lot of text and a social media post with a lot of text, and we want to join those two things together based on that text, which is really impossible for a kind of SQL-centric database to do. What if you don't know that search term that you want to type into the search box, or you don't really have any starting point? Well, this is nice because we're using Lexalytics on both sets of unstructured data, and because Lexalytics is giving us attribution that's common across those two, I can start to create joins across unstructured text. So here I'm joining on the theme of early morning between this particular terrorist incident and this particular social media post. So there is inherently a relationship between those two sets of data, and as I start to see more terms, more entities out of the same tweet and the same terrorist incident, I know that there's a stronger relationship between those two different types of data. So it really starts to uncover some interesting, unanticipated relationships there. So that's all I had. I've got 2 minutes. 2 minutes behind. Thanks very much.